In HARPOCRATES, basically, we're trying to build technologies where we try to combine machine learning with modern cryptography. So the big dream, let's say, is that we want to build services where a user from his phone or from his local computer, he can send an encrypted image and send it to a cloud. And then the cloud, without really decrypting it, which means that without really breaching the privacy of users, will be able to run some mathematics and identify with high probability the content of the encrypted image, and will send back a reply. Now, what's the use case there? Imagine that a patient will be able to send, let's say, e-health record or an MRI, which is encrypted, to a cloud service provider, and the cloud, without saying anything about the identity of the user or the actual data of the user, will be able to identify if the user suffers from disease A or disease B, and will send back a reply to the user. And even the reply that the cloud generates will be blind, which means that the cloud will not be able to know what reply sent to the user. Therefore, we first of all protect the privacy of the users, and at the same time, we can make sure that the answer that we get from the cloud is fair. Okay. So how we try to do this is we try to use some encryption schemes that are called homomorphic encryption and functional encryption. So with homomorphic encryption, we can run computations over encrypted data. Like we can calculate a function over some numbers, right? Encrypted numbers, let's say. With functional encryption, we can do the same, but there are some fundamental differences. So in homomorphic encryption, first of all, the generated ciphertexts are quite long, and the processing time that it required in order to encrypt data, it's quite high. In addition to that, the generated ciphertexts are very long, so the size of the ciphertext of the generated ciphertext it's quite high. So we try to avoid this by using functional encryption in first place. And what we do with functional encryption, we again are able to calculate some functions over encrypted data, but in a slightly different way, right? Which makes the generated ciphertext, first of all, smaller. The processing time is much lower on the client side, which makes the whole thing more efficient, but also it is more secure. So what is the fundamental differences between functional encryption and homomorphic encryption is that with homomorphic encryption, there is one key that if someone holds it, it can decrypt everything. In functional encryption, this doesn't exist. So we have a bunch of users that all of them are generating their unique keys, and they encrypt their data with their unique keys. Now, at the end, these data are sent to the cloud, and the cloud can generate what we call a unique decryption, functional decryption key, and with that key, you can get back the result of the function that is calculated over the encrypted data. While in homomorphic encryption, the cloud provider or the entity that has access to that decryption key can see all the individual bytes. This is not possible with functional encryption. So we can really preserve the privacy of users. Now, on top of that, we're using also another technique in HARPOCRATES, which is called Hybrid Homomorphic Encryption. And what it does, it's something that I call it something like black magic. So basically, in homomorphic encryption, we encrypt our data in first place locally with an asymmetric key, public key, and we send this to the cloud. So as I said earlier, the generated ciphertext is quite long, so the size is high, and the communication overhead is quite high as well. With hybrid homomorphic encryption, we switch this in the sense that instead of encrypting our data with asymmetric encryption, we just generate a symmetric key and we encrypt our data symmetrically. Then the only thing that we encrypt asymmetrically is basically the symmetric key that we generate. So all of our data is encrypted symmetrically. So the generated ciphertexts are quite small, and we send it to the cloud, which means that, first of all, the processing time is much lower, and the communication overhead is also small. So on the cloud side, when the cloud receives this data, it, with a magic way, it can transform the symmetrically encrypted data to homomorphically encrypted data and run all the homomorphic encryption functions in the cloud, which makes things much more efficient. And basically, it's something that brings us much closer into realizing homomorphic encryption based services.